Zenith as a company, we're close to 38 years old, and we started off from a very humble background, fabricating gates, grills, and sliding doors. And since that, the firm has continuously expanded to take on all types of structural steelwork. And so the firm started in 1977, so that's close to 38 years in the market. We were predominantly based in Nairobi and the surrounding areas, and we then expanded to Mombasa, then the whole of Kenya, and around 2002 and 2003 we became regional, where we started to have a strong presence in Tanzania and then the surrounding East and Central African markets. So that is Tanzania, Rwanda, Burundi, Zambia, Malawi, Ethiopia. And then we used to do work in Ghana, Togo and Benin. So that means we had at one point worked in about 14 or 15 countries. Our predominant line of business was in warehousing, footbridges and churches. But recently we expanded and grew the company into multi-storey steel building systems, which is actually a very new technology. Well, it's new in the region. It's been used historically since the 1930s, 1940s in the West. In fact, incidentally, the Twin Towers that collapsed and the Empire State Building were all built on the same form of composite steel construction. So we started to do composite steel decking in Dar es Salaam for one of the first supermarkets for Quality Groups. This was in about 2005. It's where incidentally Uchumi is now based. That was a suspended floor deck of close to 15,000 square meters. We started that, and once we finished that, we started to engage in several other multi-story buildings, ranging from 7 to 13 stories. This was one of our first shopping centers we did in Dar es Salaam. It's now where Uchumi is now based. So this was a single span suspended deck. Since then, we expanded this technology to move into 10 and 13 story buildings. So that's actually 13 story structure that we've done in Dar es Salaam with parking, and we've now done close to 5 or 6 buildings in Dar es Salaam, and having successfully completed them, we then moved and brought this technology back into Kenya, and we've now finished about 3 or 4 large multi-story buildings with this system. This is one of the most predominant, or one of our flagship projects. It's known as Sifa Towers. It is at the corner of Dennis Sprit Road and the new bypass road. It's 13 stories. The uniqueness about this building is it's twisted like a double helix. Yeah. It's a twisted double helix structure, and the top floors cantilever out by about 10 meters, which from an engineering point of view is quite substantial. So you've got large free spans without any columns in. It's quite a unique building. It's nearly one of its kind in Nairobi, and that was actually commissioned and built very, very quickly. One of the key advantages of multi-story buildings over conventional reinforced concrete. First, I should tell you more about the conventional systems. So conventionally in Nairobi, Kenya, and in the region, they use reinforced concrete, which, if you're aware, is a system where you have reinforcement bars, you tie the reinforcement, you put the shuttering, and then you cast the concrete inside the columns, you vibrate it, then you come into the slab with the shuttering on the slabs, then you cast the slab having put the reinforcement. that is the conventional way of building. It's been done for many, many years. Comparatively with steel, you prefabricate it all in our workshop. So instead of coming on site with reinforced steel and you bind it together and cast it, you come on site with pre-assembled columns, pre-assembled beams, and then you put decking sheets. So it's a dry system of construction. It's done off-site. The main advantage is speed. It's extremely quick. So generally you are saving about 50 to 60% on your construction time, marked against an equivalent reinforced concrete building. A typical reinforced concrete building on a general time frame for an average contractor, this is excluding night shift and all, can take anything upwards of 18-19 months. In steel you can finish a similar building in close to 12 to 13 months. So you're generating about 12 months saving on your time frame. Speed obviously equates to cost, so there's a cost element involved, and when you due to financing cost and also the ability to return on investment, and because you're renting out your building 12 months earlier, you are saving close to 30 to 40% on your total price. How that is generated is an equivalent steel building can be up to 10% less in cost. From 10%, you then get your financing cost, which can be between 12 to 16%, and then you've got slightly cheaper foundations because steel is more efficient, it's a bit lighter, and then you've got a reduced floor to ceiling height. We use castellated beams in multi-storey systems. We can discuss that in a bit more detail. What happens is that you fit all the services through the steel beams. This is the new technology. So what's happening is our floor to ceiling height reduces by about 300 millimeters. In conventional reinforced concrete, you usually pass the services underneath the concrete beam. In steel, you pass it through the beam. The benefit of that is you don't need 300 or 400 millimeters as your dead space for your services. That means that you're building on a 10-story building. If each floor is 300 to 400 millimeters less, your total building can be up to 4 to 5 meters less in height for the same number of floors. That again equates to a cost issue. So you're saving 4 to 5 meters of glazing and so on and so forth. So the direct cost between us and concrete is up to 10-12%. Financing 12 to 16%. Another cost saving because of your foundations, and a third and a fourth cost saving because of your reduction in glazing area and finishing area. That can therefore generate close to 30 to 40% saving in an entire project for the core structural steel frame solution, which is substantial. Many people in today's market don't equate the money aspect related to time. But when you look at the finance costs today in the market that are continuously rising, it becomes quite a high value. Steel per kilo is more expensive per cubic meter than concrete. However, you need to remember, in a multi-story building, you're using less of the material and you're doing it much quicker. So so when you equate the total volume or tonnage of steel that's going into a building, steel building, relative to a concrete building, it works out to be more economical. We are also buying steel directly from mills, so we get it at a very economical rate, and that cost saving we pass on to the client. Your walling and cladding systems are all the same. So you are cladding the building. Your cladding is your infill. This is your infill on the walls. So your infill is the same. It's still going to be masonry block work on glazing. So security systems in either case are the same. I mean, no one will be breaking through a column, will break through the wall. So security is not really an issue. Yes, it's prone to corrosion. So what happens is we, before we send the steel on site, we paint it with a rusting primer. In certain buildings that are along coastal areas, we can encase the columns. We can encase it either using a weatherboard. We can use concrete encasement, and we also paint it with a rust-resistant paint. You get epoxy paints and red oxides and chromate primers, which is what we use to combat rust.
Outsiders from all over the world, there are a lot of experts in steel buildings, but the conditions of Kenya, the expertise, knowledge, and the implementation, these three have come together for Zenith. That is more important.
It's something that I've seen abroad. It's something because I lived abroad for a number of years. I saw steel buildings fitted up in a very short period of time, and I was amazed because I came back to Kenya and I saw reinforced concrete, and I was always surprised as to how it takes so long, and you need to bind the reinforcement and put it and let, and it all seemed very cumbersome and sort of time consuming. That's how I got the idea, why not try this and bring this whole system into the country. Very, very few buildings use reinforced concrete today in England. In fact, it's exactly the opposite. It's a minority. Most buildings today are done in steel or precast concrete or dry systems of construction because of speed and time.
You know, of late we have seen last couple of years, so many new buildings have fallen down. You know. Now that is related to the quality of the work. You know, the quality of material and work. Now this being a very precise, and it's done at a workshop and then implemented. So it has to assure quality. Does assure quality. Whereas in concrete, you leave it to there are many levels. There's the contractor, there's the developer, there's the subcontractor, then there are the fundies. So you have to go at every level. The engineer can't keep on checking each and every level. You know, has it tied it properly or not? Has it done it? Has the cement been used properly or not?
Just to elaborate, what's being said is steel has got definite material properties. So you get the steel in. We have mills test certificates for all our steel. So we know that I-beam is that quality. So you send it on site, it's got that quality, and you can't change that. If that makes sense. So through steel you have a much higher level of potential quality in the building, and it's a controlled form of construction.